Okay, folks, let's get going. So anybody had any further luck in improving their scores?
I've just had a frustrating couple of weeks, really, just trying like loads of stuff and just burning through my GPU time. And like the new Google collab things, an absolute nightmare. It just, yeah, well, 2 weeks ago I had 130 hours and I burnt all of that and had to buy more credits. So
Oh, really? Wow.
Yeah, and yeah, because I was like looking at one of the previous competitions, like the Common Lit competition, and like, yeah, like the winning one in that used pseudo labels, and like there was like quite a few sort of interesting notebooks related to it. Like it used a couple of notebooks to generate the pseudo labels, and like one of them it used like pre-training by, you know, like using the mask thing. So I decided to try that, but it didn't help at all. So I haven't got very far. I haven't improved my score, but
yeah, in fact, last week, I think when we talked, Mayank was saying that there are discussions posted in this competition thread which say that the masked language modeling approach of fine-tuning, I guess, on the current data set doesn't seem at all to improve for this particular competition.
Yeah, there's one discussion thread about it, and yeah, like it makes sense. Like somebody sort of says, yeah, basically the data size is too small, and by sort of just sort of getting your base model to fine tune itself onto the existing training data, it just becomes like too limited. It can't sort of cope with the test data then. So yeah, like it explains it well. So I can understand why it doesn't work.
Yeah, that's what I was thinking. But without the mask thing, the generating, pseudo labels, I was planning on trying that too. So are you saying that that doesn't help improve things either if you use all of the feedback one competition data?
No, I haven't got as far as I've generated my pseudo labels for, yeah, like what is it, feedback 2021 data. But I haven't actually tried using it to train my model as yet, because it was just trying to improve on my score that I had before. But I've actually found as well that what I was telling you a couple of weeks ago about how you can tell if your model is better or not, that was wrong. Yeah, because I thought it was like if it appeared in the leaderboard, and like although there's only sort of 2 digits of precision, I thought if it appeared in the leaderboard saying congratulations, you've your score's the best ever or whatever, that you'd improved on the last one. And it turns out that it's not that. It's not true. But yeah, I found a way where you can see like so yeah, so like if I go to the competition, one thing I found as well, I'm not sure if people might know this already, but yeah, like I was training stuff in Colab, and like what I always used to do then when I trained my models in Colab, I used to like download the trained models to my local computer, and then I would upload them into Kaggle. So like it would take quite a while because of the fact you would like download them and then you'd upload them. Whereas I found somebody was doing this, they just like make a notebook and you share your files on your Google Drive, and then you just use GDown. So you just pull them straight into like a notebook on Kaggle, and then you include this notebook in the project that you want to get access to them from. And so like it makes things much quicker because it just pulls them over once and then they're stored. So
hang on. So what you do is you create or you install this GDown thing, and then you or you store the model that you've created from Colab onto your Google Drive?
Yeah, so for
and then
example,
pull that drive location.
Yeah, so like I've trained like Deberta V3 base here on Colab, and yeah, like can save the weights into my Google Drive. And like what I would normally have done before, I would have gone to like this file, say like chosen that, and then downloaded it, and then I would have gone into Kaggle and would have created a data set, and then I would upload this file that I've downloaded to create a new data set, and then in my inference notebook, I would use that data set to get the weights. Whereas all I have to do is if you go on here and you go to share, and then you just like choose to anyone with the link. Once you've done that, then you can just use GDown to pull them straight into a Kaggle notebook, which you can then include, just as you would with a data set, include that into your inference notebook. And it makes things like much quicker because you're not pulling stuff down and whatever. So
now, how do you, once you've done the GDown thing, like you showed here, so you, and then how do you subsequently include it in the notebook? I mean, by this you're pulling that data into the notebook. Then what's this code or step to use it?
Okay, so yeah, you've got this GDown line. So as soon as I would save this Colab notebook, sorry, this Kaggle notebook, as soon as I save it, then it pulls the stuff over. So you can see here now it's pulled all these files into data. So it's got like this data. And then when I include this Colab models download v1 into, let me move this about. Yeah, like if I was to like go to like this notebook, say, and like edit it, and then add this notebook in, then those files would be available to me. So it's using a Kaggle notebook to store data as opposed to using a Kaggle data set to store data.
So sorry, if you go back to the step where you were, so you can just actually pull in, if you just go back and then you're using it.
Yes.
Right, you do that, and then you can just, it's there in your available data, so you can just use it as is.
That's right, yeah.
Oh, okay.
Yeah, so it like makes it like a lot easier to get your trained models over from Google Drive into this. So
okay. Yeah.
Does this permanently saves it, or when you turn off your notebook, it deletes it?
No, so it saves it. So yeah, so like you know, like when you save this notebook, you know, like it runs it, and so it runs it, and at that point it executes the GDown line, and it pulls the data, the shared data over from Google Drive and saves it into this notebook's data. So you can see like all these files now have been pulled from Google Drive. And like
do you have to save and commit, or just that save where you save the notebook, you know, the simple type of save where you're just saving your edits is good enough for this?
No, you got to save and commit to make it run the line. If you just did the fast save, it wouldn't run the line because the fast save doesn't execute the notebook.
Okay. So fast save is just for editing, and you do have to save and commit. Okay.
Yeah. So like this information here from the GDown, that happened when it committed and when it ran this line. But yeah, you got to save and commit, otherwise it will not pull it. But anyway, back to the so like here, when I was like submitting stuff to the leaderboard, where am I now? You know, so I'm dropping down, but you can see here when it says your best entry. So I thought that like although we've only got 2 digits of precision here, I thought that like when I was like seeing your best entry, it meant that the one I just submitted was actually better than the last one. It turns out it's not, but the way to see if it's better or not, if you actually look at your submissions, you can order them here, sort by public score. So we've got lots of errors, but you can see now, so my best one was actually version 3. So I'd been these other versions, and I was like seeing that thing in the leaderboard and said your best entry, and I was thinking I was getting better, whereas I haven't actually got better since here. So, but yeah, supposedly like these ones here are ranked in their actual, in their score, and like although there's only 2 digits of precision, they are actually sort of properly ranked. So like this one here, this one is my best one. So it means that.
But how come? That's interesting, Steve. So if that's correct, and you're saying you've got the best score, but it is not the best score, it would still be the best score, right? Like, how would that be possible that you're climbing up in the ranks with a lower score?
No, so like this one here, version number 3, when I submitted this, I've got like 0.43, but this one here could be like behind the scenes, it could be 0.439. Whereas like version 8, when I submitted this one here could be 0.435. And so like here, these are properly ranked. So this number 3 is better than number 8 and better than number 13. So like when you submit them to the leaderboard, you can't see that. When you submit to the leaderboard, it just like says your best entry, but it's not actually your best entry. It just means, in leaderboard terms, it means that you've equaled your best entry. But in terms of which one's actually best, it doesn't tell you. So the way to find out which one's best is, yeah, as I say, to come in here and rank your submissions by their public score, and then that'll show you which one's better. So it means.
So what you're saying is, if you have to compare your own runs, then the way to do that is to do it using the rank by public score rather than just go by the best score you have received on the public. I mean, it would still appear that when it says that you have received, you have climbed up the rankings, that notebook has given you the best result, but it doesn't say which notebook. I guess you have to keep it. You have to know which notebook you submitted to get that result. And you're saying that you can recall by ranking it using this method. Am I right?
That's right, yeah. When you submit to the leaderboard, the only way to tell if you were better than your last one is if you manage to climb some places on the leaderboard. But like say you just like if you stay at exactly the same place from the leaderboard, there's no way to tell, was your new submission slightly better than your last one, or was it worse?
Yeah,
so,
that's right.
So, and the other thing is as well, like say you just wanted to, so if you just wanted to test a notebook that wasn't your best notebook, you could still submit it and you would get a score, and then you could compare it. You could submit a couple and compare which one's better if you're just sort of like trying to evaluate a single notebook.
Yeah. You have finer granularity and really know amongst your notebooks what's the ranking rather than just with respect to the leaderboard.
Yeah.
That's a good find. That's nice.
But
yeah. So I didn't know they had the option. So you're saying if you go up, they allow you to rank all of your results by the public score?
Yes.
So what are the other options?
Oh, just like by their name and by their most recent. Yeah. So. Yeah, because I thought I was getting.
And by the way, while you are on it, you get this notebook timeout versus, I keep seeing notebook through exception. Now, I'm assuming that timeout means that you ran it for too long, was right? And when do you see this notebook through exception problem?
Oh, just if you've got a bug in your code. Yeah, like if there's a problem with your.
So you think that if we run it and it says notebook through exception, then there's definitely a bug in the code rather than it's the duration?
Yeah. Yeah, if your notebook takes too long, then you get this notebook timeout error. Yeah, so like I was exceeding 9 hours for that, and then I ran out of time. So whereas these ones here, they obviously had like bugs in them.
Oh, so that's interesting because one of the things I was seeing was I have two notebooks, and I have many, but my point is that, but for example, this ensemble of whatever, Berta models or whatever, and I got that to run standalone successfully. Then I was combining it by running it with, let's say, the SVR model thingy.
Yep.
And each of them ran successfully. And I was able to submit each of them individually and get a score. Now I said, okay, let me just ensemble them. And I submitted that. And that gave an error, throwing exception. So you think that's because there is some problem in the code that would combine them rather than it running out of time then?
Yeah, like if it says it threw an exception, then it's a problem in the combination. Whereas, yeah, like this is what I'm doing as well. I'm combining the SVR one with that other ensemble of top solutions. And yeah, like that Deberta family notebook, it takes an awful long time to run. And so like when I've combined them and tried to get the hidden weights out of it, that's why I ran out of time. So
yeah. So I need to go back and debug my notebook then, because I was thinking it's probably because of the running out of time, but you're saying if it says through exception, then it's a bug.
Yeah, and you normally find as well, as I say, like you've got like 9 hours. So this one here, yeah, like at the 9-hour mark, then this popped up. Whereas normally if you're throwing an exception, it'll happen before 9 hours.
Okay, got it. So I need to debug what I'm doing wrong, because each of them runs individually. So that means I'm doing something wrong in combining them, I guess.
Yeah, I found some problems in that. I think in the ensemble notebook or whatever, it includes in the thing for the folds. I can't remember what it's called. And then the SVR one uses the same thing, but from a different data source. And I was having problems. The two of them were getting confused. So I changed the SVR one over. Now it uses the same, what's it called, the stratified K-fold thing. I can't remember its exact name.
Oh, you're saying the folding, because yeah, the SVR one uses but the SVR one was the one that uses the 25 folds.
Oh yeah, but it's like the way that it generates the folds. Yeah, so like this ensemble one.
This uses a traditional kind of stratified K-fold, I think.
Yeah, so you can see it
right?
uses this. This one uses like this
Correct.
iterative minus stratification. Whereas if you look at the other one, it also uses iterative stratification, but it uses a different version of it. Yeah, so like here, see, this is different. Although it's iterative stratification, both of them are exactly the same, but they're pulling from different data sets. And so like mine was getting confused because I was putting both of these in together. And when you put both in together, when you add it to your notebook, Kaggle does like a sort of a slight modification of the name because of the fact you've got like the name clash, but it doesn't tell you. I think what it does is it chops out the minus sign. And so yeah, suddenly like one of them wasn't working anymore because of the fact that they were just getting confused. So
that's probably what is happening, because every time I've run individually, it worked, and I'm like, what the heck is wrong with? And then when I did not have the Deberta combination and I had ensembled a bunch of them, but all of them were using, I think, the same iterative stratification thingy, because that worked. So that explains why I'm seeing things that would have taken me how did you debug that, or how did you figure that out?
When I ran the thing just by itself within the notebook, rather than just saving it, when I ran the notebook, it came up and gave me the error, I think, or something like that.
I see.
I can't remember, but it was it took a
That's,
while.
yes, probably.
It took a while, and like took 9 hours of my compute time to do it. So that's where all the times go.
No, I can imagine, because I usually run it interactively, but because I ran to success the two of them individually interactively, I assume that when I combine them, then it should work, because each of them ran to completion, which it turns out is not a safe assumption. Okay. That's a good lesson to learn. So you ran it, you're saying, interactively in combination, and when you did that, after about 8-9 hours or whatever, it gave you the error.
Yeah, it wasn't as bad as that because of the fact that there's only 3 samples in the sample test set. But it's still a couple of hours.
Within a couple of hours. Yeah, correct. Yeah, that's what I see. Yeah. Okay. But good lesson learned, right? That I think, for me at least, that even if two things work independently, combining them for the reasons may not, and it's better to run it and verify that it runs. And I also, good lesson learned that true exception means there is a bug in your code. Okay, those are 2 important things I learned today. Thanks.
Yeah.
Besides the importing stuff that you pointed out, right? Like the Google Drive sharing thing, which I think is a big boost on kind of saving your models in Google Colab and not going through a whole song and a dance of creating the data set and all that, and just pulling it in through the notebook.
Yeah, no, it's definitely like saved loads of times for me, because maybe I've just got like a slow internet connection, but it takes me a long time to download and then upload again. So
no, I mean, even if I have a slightly better connect, it's still a problem. So good. That's kind of cool. The other thing, by the way, the one other, I mean, I hopefully next week I'll be able to get some, at least the ensemble thing working. Then the other step that I wanted to do is what you're trying, which is, the pseudo labeling stuff, because pseudo labeling with all of the FB1 feedback 1 competition data, definitely I'm hopeful will help. Or should help, but who knows, right? I mean, we really don't know whether it will or not. Have any of you seen any posts which say whether, I'm sure people would have tried it by now, right? Is any posting on discussion which says whether it helps or not?
I haven't seen any
I saw a
posts that
post
say
that
if it helps,
bookmarked it.
but I was following, there's like one guy, I can't remember his name, but he had like quite a few notebooks, and he's got 3 notebooks about the pseudo labeling thing. So he shows you how to create the pseudo labels, and like how to join the feedback 2021 data together to like make it into the same format as like this competition. And then in his 3rd notebook, it's the one where he's meant to do the pseudo labeling, but he doesn't actually use it. I think he sort of got sidetracked or fed up or whatever. But in the, like, as I say, I was like looking a lot at the common lit competition. The winner of that, they basically won by just doing stacks of pseudo labeling. They basically got as much data as they could from everywhere and pseudo labeled. But yeah, I got a bit sidetracked by that, because I was like looking at the model that they used to do the pseudo labeling, which was like using the masking thing. So I headed off down the masking route for a while. So I need to come back. So like that's why I haven't actually tried it yet, but I haven't actually seen any discussion to say if it helps or it doesn't help. But I presume
I bookmarked, I think, probably the same guy you're talking about, of oh, if I get that route, this guy seems to be talking about it, so I should look at his notebook. But I haven't done that yet. The other thing I was, hopefully if I get the ensemble working reasonably, and I'm somewhere at least in the top 100 or whatever scores ranking, then I was thinking of another step I really was interested in was this distillation, right? Trying to create a distilled model, which is, a more efficient single model rather than and then I realized, oh wait, the issue here compared to what the NLP book talks about distillation is, here our teacher model is an ensemble rather than a single teacher model, right? So the book, I'm talking about the NLP with Transformer book, gives you an example of how to use a single large teacher model to get a distilled model, a student model. But I was like, wait, now we have an ensemble, so what do you do? And I found a couple of papers which talk about how to use ensemble models to create this student-teacher or teacher-student type of things. So that's something else that I just found them literally like last night. So I haven't even read or done anything, and some of them are all convolutional models, so they're not transformer related. But then I found a couple which are more transformer related, and fascinatingly, these papers are like 21, 22, October 21 or earlier this year. So I'm hoping there is enough time to be at least try it once. And first of all, I have to get into the top 100 before I really fart around with this kind of stuff. But I thought that was interesting, is how do you get, first of all, I was thinking, okay, I can just follow step by step what the NLP Transformer book does. And then I was like, oh, wait, I can't, because it's an ensemble that I'm getting to get the good score. So what do I do then? And so I have bookmarked some papers. If anybody is interested, I'll post on Slack.
Is a distilled model, does it run faster at inference time?
Yeah, it would, right? Because the distilled model would be a single simple model. It would typically would have lesser number parameters, and B, compared to all these ensembles that we are doing, it would just be a single model. That's the desire. Last week also I was asking Mayank and stuff. The example in the book that they use to show the distillation process, the student-teacher process, I think it's chapter 7 or 8 or something, is they take a BERT model and then as a teacher model, the full BERT model, and then excuse me, the student model is a distilled BERT model, which is a much simpler model. And the reason that works, they talk about this, is distilled BERT's architecture is also similar to BERT. Both are BERT based. So one of the other things I have to do if I go down that path is also figure out for DBERTA, what is a simpler DBERTA. And I think mine was mentioning last time, and that's the reason he posted the DBERTA. Instead of maybe a DBERTA V3, large or whatever, maybe use a DBERTA, original DBERTA base, and see, structurally or architecturally, it would be similar enough that it would be able to learn from the ensembles of DBERTA models that we are using.
Will that give you problems? Yeah, so at the minute, my solution, it's effectively like that notebook, like the family of DBERTA models, and then like I grab the hidden states from each of those and then stick them into the SVR thing.
Right.
If you create like one distilled model of your ensemble, does that mean you'll lose the hidden states and so you won't be able to use the SVR?
No, the way it would work is you use all of the, or I'm assuming, because so far what I've seen work, what has been shown in the book is a single large, complicated, very large number of parameters BERT model is used to give excellent results on the problem. But what you want is a much smaller, much more, when I say small, I mean in terms of parameters, a much more efficient, therefore a more efficient model. So you use a much smaller model, and your latency, therefore, of how quickly it runs and how fast it predicts is much better. And that's what they demonstrate, that, you know, if you want to use, for example, and because there is an efficiency price also in this competition, right? And they want you to also think about efficiency, just like FP2 competition. So I was thinking, wow, I mean, if I have time left over, then this is an interesting thing, because I have never done the distillation process. But then so that's a long context to answer your question of, so you use all your ensembles and just use them to train the student model. The student model is a single model. That's just, I assume, I'm going to make this up because that's the thing I don't know yet, is what is a simple DBERTA. So let's say a single DBERTA based model. And so what you're using or what you're doing is using all these, I don't know, 15 models, including the SVR model, hidden states and stuff, to train the weights for a single DBERTA base model whose performance would almost match, sometimes even exceed, the performance of these 15 models.
All right. Yeah, because I thought that, yeah, I thought you were taking, like, say you're like 15 DBERTA models, which are in an ensemble, and just creating one, but I didn't realize you'd be able to put the SVR thing into the distilled model as well.
Yeah, it's the, you're just, you know, this is why I still have to read the papers to make sure that I learned how to use ensembles to teach a student, but the distillation process is designed to help a large, complex, or to help a student, which is a simpler, architecturally similar to the teacher model, to achieve the same or almost equivalent or sometimes even better performance compared to the more complex teacher model. Now, what, you know, the two things in this case that I still have to figure out is, what's the simple model, student model that I can use? Is it a DBERTA base, for example, as Mayank was suggesting? And two, how do I use this ensemble, and which the ensemble uses the SVR model to perform as a teacher for the student model.
Right.
And that's where I'm hoping that the papers come in of use, because the book talks about the simpler case of just using a more complex model of the same architecture like BERT to teach a simpler student distilled BERT model to perform equivalently or even slightly better.
Yeah, like even if you could do that, yeah, so say that you have like 10 DBERTA models in your ensemble. If you could like distill each of those 10 to make their inference go faster, so as you get the hidden states for the SVR thing, that would help a lot anyway, because at the minute, you saw there, like my thing was timing out. So I was taking, like in the original Christie notebook, it just takes like the 10 DiBerta models untrained and just uses the hidden states. It doesn't use the trained ones. So yeah, like what I'd started doing was like taking the ones that had been trained on this problem and using their hidden states. So for example, I was using like the base one where I had like 4 trained models because there was like one for each fold. And like that gave me a boost in the score. And then I'd like taken my next one, which was a 5. But like as soon as I did that, because of the fact suddenly I had like 5 folds to process or whatever, then I ran out of time in the notebook. Like that's when it was like going over 9 hours. So if I could get distilled versions of each of those trained ones that had faster inference, then I could put more trained notebooks into the ensemble, and that would help.
I see where you're going. Those are the things I kind of don't know how to do right now because it's just, a single monolithic large model used to train a single simple monolithic student model. That's what is discussed in the book. And variations thereof of using ensembles and the way to use ensembles and using hidden weights of ensembles, those are the things which, in fact, I was at least trying to identify papers that I could tap into or look into if I have the time of how to do that. I'll post some links on Slack when we are done.
Okay.
Because that's the only other way I can think of to kind of work. Because, there is an efficiency challenge too, and I didn't attempt anything in that space in the last competition. So I thought if there is time, it would be interesting to do. And B, that's the way to get around. I was thinking if we get anywhere close with the student model, then it's a way to get around the time restrictions as well, right? Because you can combine the ensembles, but you can have, multitude of these ensembles trying to teach the student. Like you say, it can be used potentially to reduce the time as well.
Yep.
Yeah, in fact, one of the reasons that they do the distillation is to reduce the latency of inference.
Yeah, no, like that would help a lot.
Sorry?
That would certainly help my notebook a lot because, yeah, that's where my sort of bottleneck is at the minute. I'm just running out of time to get the hidden states from trained models.
Yeah, that's interesting. So any other thoughts or comments, Mike? Have you been able to try anything else different?
No, I've been along the same lines as Steve and you. So yeah, stuck into the same pitfalls as this competition holds. I haven't been able to try anything radically new. I was still thinking about the pseudo labels too. I haven't implemented them yet, but yeah, I was thinking about them, of how they could be of use to us. But I don't think so. These pseudo labels have helped anyone because most of the Kagglers must have implemented it since it was the main feature of the last feedback competition too.
Yeah, that's what I was thinking. But on the other hand, one of the other crowd behaviors or something that I've seen as well is like if in FB1 feedback 2 competition, I think that people were talking obliquely about this secret sauce of how to get the score, but nobody posted any notebook that actually used it at all. So it's possible that if it really gives a better score, then many people may be trying it, but not posting it either, because that's a phenomena I observed with the feedback 2 competition, because, in that one, if I don't recall the details, but the way you encoded it, if I remember, made a difference. And, so people refer to it obliquely as the secret sauce to the encoding, and anybody who used that were all in a higher category. But the counter argument to that in this case, where it may be that you're right and nobody has figured out that even though they've implemented pseudo labeling, it's not giving them much boost, is also because most people are still stuck at 0.43, but that doesn't say much, because unfortunately, as Steve has mentioned before, and as we have seen, the hidden digits seem to make so much difference, which is why there have been like umpteen requests to the organizers of the competition saying expose the last 2 digits, because otherwise help us, or tell us what it is, because otherwise there isn't any good. I mean, as Steve illustrated, you can find your own, but there is no way that we are able to find out, is there a bucket on top of the 0.43 score that significantly separates people who are, say, using pseudo labeling versus not. You see what I'm saying? Meaning, A, they may not be saying it even though they're seeing the advantage, but B, we are not able to see that that's what is driving the advantage. But on the other hand, we have a data point, which is Steve's rank is 31. And so if anything, even assuming that the guys immediately above him are doing pseudo labeling, it means that only the top 30 people are doing something. And that's a lot less, or I don't know. I mean, kind of, there are multiple data points as to whether pseudo labeling really works or not for this competition. But I also agree with you that it's kind of strange that nobody has said anything.
Yeah, I said the other week about somebody posted in the discussion thing, sort of saying that the reason it seems to be stuck on like 0.43 is because of the fact that none of these models are very good at classifying the sort of the low and the high scores, like the 1.0 and the 1.5 and the 4.5 and the 5.0 scores, because of the fact that like the data is like so imbalanced. There's like so few examples on them. Yeah, like I tried sort of using data augmentation and tried to sort of rebalance the data set, but I didn't have any luck with that either. I wasn't sure if you know of any techniques that you can sort of
previously, right?
You don't know any techniques where you can sort of rebalance the data set to get more of those low and high scores?
Yeah, I mean, the traditional ones, and in fact, there's all kinds of opinions on that topic as well, right? Like, I think Jeremy contra everyone else seems to think it really doesn't matter whether you do that and he's talking specifically about convolutional kind of data, a little bit of language data too. I think he seems to think within a ratio of about 3:1, 5:1, it doesn't really matter, and your models won't improve significantly. Obviously, the people who advocate for adjusting it are primarily the method seems to be duplicate data, and then in your final model, when it's running, make sure you train once on the non-duplicated data. I mean, do all the initial training on duplicated data, but then run it once on the non-duplicated data to make sure that the model realizes that the actual data is going to be skewed, not evenly distributed as you have trained on. That's something I learned from the end.
Do you mean train it with sort of, with like the with the balanced data, and then train it again for a couple of epochs with the unbalanced data, with the original data?
Yes, yes,
Right.
yes. That's in fact something I learned in the NYU data science course, and from Jan LeCun. And the reason he gave for that, which makes sense to me, is, and he was talking, for example, about an example of radiology data or whatever, right? Like, because that's heavily skewed in one direction. So he was saying duplicate, the other direction to make it balanced, train it that way. So, and then though, exactly to your point, run for a couple of epochs eventually with the unbalanced data, because the reality is that it will see the unbalanced data in the wild. That's the data it will actually see, the model. And you don't want it to think that it will only see balanced data. And that's the reason to eventually run a couple of epochs with the unbalanced data. I had not seen anywhere else people say that. Jan LeCun himself says that in a lecture.
All right, I'll try that, because yeah, like I get a feeling that all my models are just like learning to predict around the 3.0 mark, just because of the fact that you can sort of be right most of the time if you sort of predict towards the middle, because there's so many examples. And so I don't think they ever sort of predict 1.0 or 5.0, because they can get a better score just by averaging out and being in the middle. And I think that's why everybody's sort of stuck at 0.43.
Yeah, that's where I was thinking that pseudo labeling should help, but I don't know whether it will, because the model or let's put it this way. I'm just openly speculating here. This is purely speculation on my part, but indulge me. The original FB1 dataset, I assume, which has more of a spread in grades. I think, if I recall correctly, it has, 6 grade, maybe grade 6 to grade 12, which is like 6 levels of 6 student class levels or grades or whatever you call it in wherever you are, but 6 years of education, if you will. Whereas I think, if I recall correctly, FB, the current one is narrower, 8 to 12. And the reason I bring that up is there's more of a possibility, I think, and based on even the FB2 data that we saw and some of the examples of essays that I've read, is the 1 scores, meaning poor scores, likelihood is probably higher in the feedback competition 1 data, because some of the essays are really terrible. So you will kind of see the spread in the 6 classes a lot more if you actually humanly graded or provide the 6 levels. Now I'm talking about, this syntax, vocabulary, blah, 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 and for the entire corpus of feedback 1 competition. Having said that, the problem I see is pseudo labeling itself is again done with our current model, right? So
Yep.
if our current model is unable to predict or does not predict the 1s and 5s very much, then we have a problem, because even though the original data is going to have the 1s and the 5s, if our current model doesn't predict them, then the pseudo labels will also not have as many 1s and 5s, even though the real data does. You see what I'm saying?
Yeah, that's what I was like thinking. Like, that's part of the reason why I haven't sort of gone ahead and used the pseudo labeling thing, because as I say, I'm pretty sure my models just predict around the 3 mark, and they don't do very many 1s and very many 5s. In the common lit competition, the guy, he used sentence BERT, and he used sentence BERT to predict the similarity of his external data with the training data, to try and sort of use that. So I don't know, is that possible, where you would use like sentence BERT to like look at the feedback 21 data and see which ones compare with sort of the 1s and the 5s of the current data, and like label it up that way instead of using the model.
Ah, interesting. Yeah, that's an interesting approach, because I was thinking, again, impractical, but at least to guide my thought, I was thinking, what would ideally work, and then back off from there. And your approach seems to align with that, because I was thinking ideally what you would want to do is get humans to grade the feedback 21 competition, and they would be able to grade and give the 1s and the 5s, right?
Yep.
To the data, because they would not only predict in the median, they would say, okay, this is a 1 and this is a 5. That's your kind of golden approach. And you want to kind of back off from that and try something automated. And so your approach seems to be aligned with that thinking, right? Because you want to indirectly emulate a human grader giving you 1s and 5s to increase the actual to increase the 1s and 5s in your data corresponding to the actual 1s and 5s in the underlying data.
Yeah.
So that approach that you just articulated seems to make a lot of sense.
I was thinking as well, though, like it's like maybe hard to sort of get two pieces of text and compare their similarity and say, yeah, so like one of the pieces in the training data might have like a score of 1 for, I don't know, say the syntax category, but yeah, like it might all be 3s in the other ones. So what I was thinking as well, it might be easier to split it into the 6 separate categories and have like 6 models and trying to find similar data for each category as opposed to similar data across all the categories.
Yeah, that may be true, that you're saying further have 6 models, each one just predicting a single category similarity.
That's right, yeah, and try and use the pseudo data then, and like try and find similar data just within a category to make it easier to sort of say if it is similar or not.
Yeah, that obviously would, I think, be easier on a model than trying to predict 6 categories all in with one model and find the similarities in their scope. Because that makes sense, because you're trying to predict over 6 degrees of freedom, so to speak, with a single model.
But the only drawback is that you're training 6 models, and I've already run out of computing time. So
yeah, but wouldn't you? But this is all offline though, right? Because eventually your goal is to get those scores and then import them into this model, right? So all the work that these 6 models and stuff would be doing would all be, but you would need to generate a pseudo model on a pseudo labels on the test data, right? Yeah,
that's right. Yeah,
that would pretty much derail. In fact, I think. I haven't anybody looked at the efficiency scores and the single model scores, and I think I saw someone post in discussion that they have a single model that does a 0.43, which I thought was very impressive, but I haven't read that post yet. Anybody look into that?
Yes, there is a guy named Kelvin who is at the top of the leaderboard public 2, and he has the same efficiency rank, the first rank here too, as 0.443. So he is top in both the leaderboards for the
he
efficiency.
is actually at the very top. Can you pull up that post of his?
Let me try to find the post, the discussion, I hope. No, there's no discussions with him. There's no discussions as.
I did see a discussion. There was, yeah, like as you said, Srinivas, there was like somebody said they've got a 0.43 model and they describe what they did to get it, but they don't actually publish the notebook. There's a discussion about that. And like they say that one of the things that helped them a lot was just the weight initialization, you know, like the, whatever it's called, the hay initialization, the HE initialization. And yeah, in the discussion as well, it's like talking about, I can't remember what else, but like it lists sort of the techniques they used and just to get a single model. But I don't think it's like that guy Kevin that you mentioned, Mayank. I think it's somebody else.
Interesting.
Yep. Somebody else here. Oh, we will need to find that post. But yeah, I think so. If I find this, I will post it in the comments, in the Slack comments.
I found it now. Sorry.
Okay.
Where's my Zoom gone? Yeah. So it's this thing.
Yeah. Yeah. That's the one I think I was thinking of.
Yeah. So I haven't done any of these things, I don't think. But yeah. So yeah, one of the ones. Yeah, so I'm not sure if my models are doing any of these at all.
By the way,
tried like this.
one thing which you may be able to do very simply, Steve, is this because you're already using that in the SVR, right? Is the hidden layer stuff. And all he's saying is he is concatenating different embedding layers. So he's not just using the top hidden layer, but I guess further layers down and concatenating them as well and weight averaging them.
Right.
That's the sophisticated regression head.
Yeah, like I was just doing sort of what Chris Diotte was doing with his. So,
Right.
but as I say, unfortunately, he doesn't share his notebook to show how to do this.
But you know, it's kind of amazing that it is, if it is with a single stuff that is getting almost to your level, right? If you're 31st and he's 38th.
Yeah.
Yeah, which is why I'm optimistic about the distillation thing. That maybe if you can try the distillation stuff, then you can, you know, it says that with the right set of parameters and a combination of weights and stuff, you're able with a single model and the same architecture to get up that high, right? So that gives me hope that the distillation thing is actually a viable technique to get the single model up to that, at least close to that level.
Yeah.
Interesting. So how much time is, I think this ends in November or something. So we still have a month or so left, right?
Yeah, like on the competition page, it was like still saying 2 months left, but it does feel like it's gone on for a long time already. So I'm not sure exactly when it finishes.
Thinking as well. Let me check out what it says on the overview or page or whatever. And is it rules? Timeline. Where's the overview timeline page? Overview. No, this is the wrong one I'm looking at. Sorry.
It finishes on the 29th of November.
Okay. So
About a
about,
month,
well,
month and a half.
month and
Is it?
half. Yeah. So we still, I mean, in a way, it's good because you can try different things for an employee. At least I'm hoping that I'll continue to try different things. So it gives a little bit more time than when you're scrunched and you just kind of say, okay, I'm done. So I'm hoping I can get to the distillation part in this competition. I've never done that. So that's one. Plus, how to distill ensemble is something, good thing to have in the pocketbook, I think.
Yeah, no, sounds
Cool.
good. I've tried nearly everything though, and yeah, my biggest challenge at the minute is the fact that I'm just running out of GPU time now. Obviously, with Colab changing its pricing structure, it's been a real pain.
Yeah. So you
I
said you
was
had to buy
thinking,
credits, right? So how is that incrementally available? What did you have to do?
yeah, so like just on the Colab page or whatever, you can just go in there and you can pay like another $10 or whatever, and give yourself like another $100 of credit. But like obviously that's GPU hours, which on their basic like GPU takes 2 credits per hour, so it's only 50 hours worth in real time. So yeah, like it's massively decreased than before. And as I say, because of the fact that like the ensemble I have sort of takes 9 hours or something to test, and when you're generating pseudo labels, and plus as well that Deberta family thing, it uses 10 folds per model, so it obviously takes a lot of time. So I was gonna like look and see, is there any other sort of cheaper options available? And the other downside of Colab is it doesn't run the Rapids thing, so I can't even run that on it.
Yeah, the Paperspace, I think, I don't know whether it is that much cheaper, but it's, I think, an interesting option if you want to check it out.
I saw there was like the Twitter thread like that's linked from the discussion on Kaggle, and there's a couple of people saying about ones in India. I suppose there's a couple of cloud providers in India that sound pretty cheap, so I was gonna take a look at those.
Interesting. Yeah, I don't know how much cheaper. I haven't really looked into that space recently. I am assuming that in short order there would probably be, or I should say more appropriately, I'm hoping that in short order there will be more GPU cycles. I mean, not in, when I say short, I don't mean in the next month, but in the next several months, I'm assuming that things should improve with respect to the cost. If anything, the price should go down, I'm hoping, because on the one hand, the NVIDIA is increasing the pricing of their new GPUs. On the other hand, I am hearing that there's a tremendous glut of, the crypto mining thing that's overdone, and a ton of those are lying useless now, given the crypto values and all that kind of stuff crashing. And so that's flooding the market. And in fact, somewhere, and I don't know how much to trust this, but somewhere I read that, NVIDIA actively, in some cases, is purchasing and destroying those in order to not let the market just get flooded with those.
I was just reading actually like NVIDIA's new GPU, suppose it's got problems where it melts itself. It gets so hot, it just melts, and they're going to have to withdraw it.
Yeah, I didn't see that, but I did see a post which indicated something that, given my background in hardware, I'd seen personally why, and I was, among those guys instrumental in changing Intel's direction from using a single large honking CPU to using multi-core, and it was because of this problem that you can't actively continue to increase single thread latency performance just by making things bigger because you run into the power problem faster than anything else. And I think NVIDIA is beginning to realize that even with the multiple cores and whatever they call it, SP and multiple threads, they are running into the same problem. They keep increasing the power, and at some point that is a bound to it. So I'm not surprised that they are hitting that bound at about what they are doing right now.
Yeah. Did you see Yuri's
Because
post there? He said that crypto
basically,
miners don't use GPUs.
sorry?
Yuri just put in the chat saying crypto miners don't use GPUs anymore.
Yeah, I think
yeah.
successful miners, yeah, I forgot what it's called, but it's like a dedicated design.
ASICs. Yeah. They use dedicated ASICs, but a lot of these were still, I mean, in fact, the reason I know this, Yuri, is also because NVIDIA, if you look at it, they were selling a ton of GPUs to the crypto miners. So although many of them had switched, not all of them had, because the ASICs cost a fortune as well, and it's very specialized. So unless you're very big, you don't do that. You just, so the volume space was still occupied by the GPU guys.
Okay.
The very high-end guys who were doing, a ton of it had specialized chips, but they were specialized, so they cost a fortune too. And the reason I know that is NVIDIA's fortunes were in the data center were heavily tied to it. And so the prediction among semiconductor analysts is that their stock is going to take a hit going forward because their penetration into the data center market is severely impacted by the lack of demand for crypto mining, which was a big segment of the market for them. So I'm hoping, but time will tell whether my hope turns into something real or, quote unquote. But the countervailing thing is everybody is increasing prices now on GPUs. Ideally, for example, Intel recently introduced a new GPU, so those things should cause a price drop. But given other dynamics, both NVIDIA, Intel, AMD, all of them are increasing prices on their latest products. So we'll see. Okay. Anything else anybody wants to bring up?
Nope.
Wow. Melting PCU power supplies. Now that's interesting. You connect it and you see smoke coming out, literally.
Yeah. It might be good here in the UK. I'm not sure about everywhere else, but like our energy prices are rising massively mostly due to the Ukraine crisis or whatever.
Right.
So I could do with a GPU to heat my room up. See if we turn the heat on.
And have an attached fan and melt your thing, but at the same time, at least it's good heat generator.
Yeah.
Yeah, that's true. Yeah, there's a big. I hope Arto is doing okay. I haven't checked up on that guy. He was kind of.
Yeah, like I haven't seen him on here in a few weeks now.
Yeah, I haven't seen him on the any of the channels, and he was in something. I think he was in the West, but if I remember correctly, I think even the Kharkiv was other places were bombed in retaliation to the Crimean bridge thingy.
I think he went back to Kiev actually. Last time he talked to us.
Yeah, like he said, he'd moved his mum over to the West, but he was going to go back to Kiev. So.
Oh, well, hopefully he's okay. I'll send him a note. Okie dokie. Thanks for joining, everybody. Hopefully we'll make some progress by next week and see some at least results of experiments, even if the scores don't go way up. And I'll post some of the links to this Ensemble-based distillation.
Okay, cheers. See you next week, guys.
Thanks. See you all next week. Bye.
Cheers. Bye.